with the first question, the optics, about the Stiles-Crawford effect. So just to recall your memory from the lecture, do you remember where was the Stiles-Crawford effect? Do you have any clue where it was mentioned? Okay, can you tell me what is the principle that Stiles-Crawford effect based on? Are you sure it is chromatic aberrations, Dr. Sadia? Okay. So yes, your answers are right. Sorry, let me check. So no, it is the C. It is limits the visual effects of spherical aberrations. So what is the principle of the Stiles-Crawford effect? That it limits the sensitivity of the cones to the light that enter the eye in the oblique direction more than that which you enter through the axial direction. In other words, when there is light entering the eye in the axial direction, it will stimulate the light receptors or the photoreceptors more than those who are entering the eye in the oblique direction. That's why the D is wrong. As in D, it says rays of light entering the pupil obliquely stimulate the photoreceptors more than those who enter the axially. This will be wrong. If we have here a photoreceptor like this, and there is light rays that enter the photoreceptors axially, it will cause much more stimulation of the photoreceptors than those who are entering the photoreceptors or hit the photoreceptor obliquely. This is what's meant by the Stiles-Crawford effect. And the Stiles-Crawford effect occurs due to the spherical aberrations. It is one of the mechanisms that limit the effect of spherical aberrations. So when we have like a dilated pupil and light rays entering the eye from all directions in the center and the paracentral and in the periphery, what makes the peripheral light rays have minimal effect and cause minimal aberrations is that there is one of mechanisms called Stiles-Crawford effect. So it appears more in the dilated pupil, not in the small pupil, and it can cause alteration of the perceived color of the monochromatic incident light, not the saturation. We will know what's the difference between the color or hue, in other term, and saturation in the color vision in the physiology. So the Stiles-Crawford effect doesn't cause the alteration of the saturation, but it will cause alteration in the perceived color of the monochromatic light. So let's say, for example, if we have a red color or red light hitting the center of the cone or the apex of the cone, and another red light of the same wavelength that hitting the cone from the other direction or from the oblique direction, we appreciate there is a difference in the color or in the hue of the red color here and red color there. Not saturation, but the color or the hue. So here is the principle of spherical aberrations. What happens in the spherical aberrations is due to the prismatic effect of the periphery of the lens, this will cause refraction of the light of shorter wavelength more than light of longer wavelength. So this will result in multiple foci. So the image will not be sharp or will not be crisp. This is due to the prismatic effect of the lens periphery. There are different mechanisms, and as we mentioned in the lecture, there are different mechanisms to neutralize this spherical aberration. Like the cornea is more flattened in the periphery, making it more aspheric, so there is no spherical aberration. The iris also will cut the peripheral rays, and the central portion of the lens has greater density or higher refractive index, and the retina has also sharing a rule by Stiles-Crawford effect. So the cones are more sensitive to light that enters the eye paraxially than those who are enter obliquely through the periphery of the cornea. Here is the Stiles-Crawford effect, is that the light entering the pupil or entering the eye near the edge of the pupil will produce less response to that to the light of equal intensity entering near the center. So this is like a matter of differential sensitivity of the cones to the light, whether it is enter in the center or paracentral or oblique or from the periphery. And this will result in that the color or the observed color of the monochromatic light will be different to that of the same wavelength. So although there are two lights of the same wavelength hitting the cone, this will the observer will see two colors, not only single color, because one color or one ray will hit the cone from the center and the other will hit the cone from the periphery. This is again one of the consequences of the Stiles-Crawford effect. Okay, is it clear? Okay, let's move to the next question. It will be also about the Stiles-Crawford effect. So, Dr. Joan, do you think that the Stiles-Crawford effect will be less with pupil, with the small pupil? So let's say that we have a small pupil now, allowing only the central light rays to enter the retina and to hit the cones from the center. Would you expect that the Stiles-Crawford will be more or less? Okay, so as we mentioned in the Stiles-Crawford effect, we cannot demonstrate it in absolute darkness because Stiles-Crawford effects mean that there is a differential sensitivity of the cones when they are stimulated by the light. So if there is no light, then there will be no Stiles-Crawford effect. It has no relation with vitamin A deficiency, and it is greater after pupillar dilatation actually, because when we are dilating the pupil, we said that the Stiles-Crawford effect is one of the mechanisms that will limit the spherical aberrations by preventing the peripheral light rays. So what happens if we increase the pupil dilatation or increase the size of the pupil? This will result in much more peripheral light rays to enter the retina. And this Stiles-Crawford effect will be more pronounced because much more peripheral light rays are hitting the cones from the periphery, and they are cancelled or they are counter affected by the Stiles-Crawford effect. But if we have a small pupil, then the Stiles-Crawford effect will have no role here because already the central light rays are entering the retina, so there will be no action of the peripheral light rays. And as we mentioned, it will limit the effect of spherical aberration rather than the chromatic aberration. So here what's happening in the case of spherical aberration. We said that the light rays are making multiple foci due to the periphery of the lens. It will cause a spherical aberration. So what we need to do is a small pupil allowing the central light rays. But what happens if the pupil is dilated? This will allow the peripheral light rays to hit the retina. And the peripheral light rays will not have the same effect as the central light rays due to differential sensitivity of the cones due to the central light rays and the peripheral light rays. This is what is meant by the Stiles-Crawford effect. So I hope that this is clear. Let's move to the next one. Okay, yes, that's right. Let's analyze this question regarding myopia. Which one of the following statements is most likely to be true? A patient who has myopia, high myopia of -10 diopter, and he is wearing spectacles, present at the normal back vertex distance, like about 14 millimeters, and he wants to start a contact lens. So we mentioned in the lecture that there are some changes that happens when we are shifting from contact lenses to glasses or vice versa. This is like the magnification, like the power needed, and like the visual field. So one of them is the power. How is the power changed when we are shifting from glasses to the contact lens? Well, in the minus lens, it will cause decreasing the power, while in the plus lens, this will cause increasing the power. Meaning that if we have a minus lens glasses, this and we want to shift to contact lens, this will result in decreasing of the power needed. So the contact lens power required will be less than -10. This is wrong. So we don't need to calculate, or we don't need to memorize numbers, because we by knowing the rule that we need less than for minus lenses, we need less contact lens or less measurements for the contact lens, and for the plus glasses we need more measurements for the contact lens. An undercorrected myope patient will see better in the distance if he pushes his glasses down his nose. This is not true, as we mentioned that the myope tend to push his glasses toward his eyes in order to gain more magnifying effect. So if he is undercorrected, then he will try to push his glasses toward his eyes to decrease the back vertex distance and to increase the magnifying effect, or to increase what is called the retinal image size. The reverse will occur with the hypermetrope. So the hypermetrope who is wearing a plus lens and he is undercorrected, he will tend to push his glasses down to his nose, as those who are having presbyopia and needs a correction or needs to change their correction or need to change to increase their plus lenses, so they will tend to drag their glasses over their nose in order to gain more magnifying effect. In regular astigmatism, the principal meridian are perpendicular or 90 degrees to each other. This is correct. So this is the principle of regular astigmatism. That's why it's called regular, because the principal meridia are perpendicular to each other or 90 degrees to each other. Back vertex distance does need to be specified if the prescription is less than 5 diopter, not 10 diopter. So if it is like 6 or 7 or 8 or 9, they will still need to be specified to guard against the altered image magnification, as we mentioned in the lecture. So we said that the power of the correcting lens, if we are changing from spectacle to contact lens, will be calculated from this rule. The power of the contact lens will be equal the power of the spectacle divided over 1 minus the back vertex distance multiplied by the power of the spectacle. So in case of minus lens, like the example, minus 10 diopter will result in, if we are shifting from spectacle to contact lens, this will result in minus 8.85 diopter. So the actual power of the contact lens will be less than that of the spectacle. In the regular astigmatism, we said that the horizontal and the vertical or the principal meridia are perpendicular to each other. However, whether it is the principal meridia are in the vertical and the horizontal direction, like in the 90 and 180, or they are oblique to each other. So in both conditions, the regular astigmatism is the principal meridia are oblique to are perpendicular to each other. This is not the case with the irregular astigmatism. Another question about high myopia. So when we mentioned in the lecture that there are some advantages of shifting from spectacle to contact lenses, this is one of them. One of these advantages that the glasses have prismatic effect of their periphery, and this prismatic effect will increase if the correction is increasing. So if there is a patient who is wearing plus 10, for example, if he is has hypermetrope or he is a fake with high hypermetropia, he wear glasses of high plus lens. Also, those who are myope will wear glasses of high minus lens. These lenses will be thick, and the periphery of their lens will induce some problems, like the prismatic effect will cause some problems like the peripheral aberrations. So these aberrations will be more if they are wearing a spectacle, not if they are changing to contact lens. So A is not the right answer. Can you think of another answer? Yes, exactly. It is the C. So why is the C is the right answer and why other options are wrong answer? Symptoms of presbyopia may be more evident. Well, symptoms of presbyopia may be more evident if the image is less magnified, meaning that when you are seeing a near target, then the presbyope will cannot see it because the image is small, so he needs more magnification. But actually, what happens if we are shifting of high myope minus lens minus spectacle to high myope contact lens spectacle is that we are changing the minus 10 to minus 10 of a spectacle to minus 8.85, as we just mentioned in the previous question. So we are putting less minus lens as a contact lens in front of the patient's eye. So this will result in less magnification. The image will be less magnified, or in other words, it will become more magnified. So the minus contact lens will cause more magnification of the minus spectacle, resulting in that the symptoms of presbyopia will be less evident, not more evident, as the patient will not be complaining of a small sized image. The field of vision will be the smaller. This is the correct answer because the field of vision will because of the prismatic effect, as the prismatic effect of the minus spectacles will cause increasing the field of vision. When we are shifting from a spectacle to contact lens, we will lose the advantage of large field of vision in case of a minus spectacle lens, and the reverse will occur with hypermetropia, as plus lens will cause smaller field of vision, as we will see now. Retinal image size will be smaller. We said no. We said we are shifting from high minus to smaller minus. So this will result in less magnification. So the retinal image size will be larger. As we mentioned, there are some side effects of the spectacles. For example, there are some distortion due to the prismatic effect of the lens periphery. Like, for example, what's called the pincushion effect in the plus lens. This pincushion effect of the plus lens will cause more field, or increasing the magnification, increasing the field of the plus lens. And this occurs due to the unequal magnification between the center and the periphery of the lens. On the other hand, so the pincushion, the barrel distortion, this occurs with the minus lens. This will cause increasing the visual field. So a pincushion distortion occurring in the hypermetropic lens will cause decreasing the visual field, while the barrel distortion that will occur with minus lens lead to increase the field. So what happens if we shift from spectacle to contact lens? In case of minus lens, we are losing the advantage of larger field. So this will result in smaller field. Hypermetropic patients reduce their field of view by wearing a spectacle. This is why, because that the lens act as a base-to-base prism. A base-to-base prism will cause limitation or smalling of the visual field. So the light rays will be directed toward the center, as we know that the light rays are shifted toward the base. But when they are changing to the contact lens, they don't need to move their eyes so far to see the small overfield view. So it is better to give these patients the contact lens in order to improve this visual field limitations. On the other hand, the opposite occur for myopic patients. These myopic patients who are wearing spectacles, they have a prismatic effect of the lens periphery, which act as apex to apex. So the light rays will deviate more toward the base, leading to expansion of the visual field. They have increased the visual field because of the prismatic effect, as the base is away from the visual axis. So what happens if we are shifting from spectacles to contact lenses? This will result in smalling of the visual field. So the field of vision will be smaller if we are shifting from contact lenses to contact lenses from spectacles. I hope that this question is illustrated and more clear now. So as you can see that the optics questions, they need a lot of thinking and consideration. They are not that questions that can be taken lightly without proper consideration and thinking. So please take your time while you are reading the questions, and actually in the exam you will have time, because the optics exam will be having like 1 hour and a half, which I think that it will be appropriate for 30 questions or 45 questions. So here is the effect of the back vertex distance on the image size. What happens if we are shifting from spectacle to contact lens? In case of minus lens, this means that we are decreasing the back vertex distance as we are going from outside to inside. This will result in increasing of the image size. So the retinal image size in case of back vertex, in case of myopic lens, this will increase when we are pushing the lens from outside to inside. Like, for example, if we are shifting from a spectacle to contact lens, or even when when the myope is pushing his spectacle toward his eye. As he is pushing the spectacle toward his eye, this will result in decreasing the back vertex distance, gaining more magnifying effect, and gaining more size of the retinal image. Okay, let's move to the next question. Exactly. So, what is the measurements of the aphakic eye? The optics of the aphakic eye is different from the emmetropic eye, because we are removing like about a third of the refractive power of the eye. Lens is removed. So all what is remaining left is the power of the cornea, which is between 42 to 43 diopters. Other corrections or other numbers are wrong. Why is that? Let's see. For the cases of optical corrections of hypermetropia caused by aphakia, this will result in that the eye become highly hypermetropic, as the only refractive power is left is that of the cornea. The F1, or the anterior focal point, will be 24 millimeter in front of the cornea. The second focal point, or the F2, will be 32 millimeters behind the cornea, and the nodal point will be 20 millimeter in front of the retina. When we need to correct this, we can correct it with a plus lens present at the anterior focal point, like here. And this plus lens should be between should be 17 millimeter in front of the eye, or 24 millimeters of the f1 in front of the nodal point. And this is actually doesn't occur, as we don't place the spectacle here. In this case, the spectacle needed will be 10.4 diopter, but actually we place the spectacle in the spectacle plane, which is about 13 millimeter in front of the eye, so that the plus lens needed will be, should the power should be increasing as we are moving from outward to inward. The spectacle, or the power of the correcting lens, is increasing. So in the spectacle plane it will be 11.7 diopters. Okay, let me just give you some clues about the answers in this question. Regarding anisometropia, a patient can only have anisoconia if the subjective refraction is significantly different between the two eyes. Well, the subjective refraction is actually one of the reasons why patients can develop anisoconia if they are a significant difference between both eyes. But it is not the only reason. There are some anatomical reasons that will cause anisoconia rather than the refractive reasons. So this what makes the A is wrong. A patient with high anisometropia is more likely to have a good stereopsis using a spectacle other than the contact lens. Again, we said that this is not true because actually patients with high anisometropia, this will result in anisoconia. So the anisometropia with the spectacles, this will cause different in the spectacle magnification or what's called the relative spectacle magnification. So if they are having a metropic eye and the other eye is plus 10, for example, this plus 10, when we are using a 10 diopter lens in front of this eye, this will result in 1.3 magnification of this image over the normal eye. So this magnification factor will cause of the brain has difficulty to fuse the images from the two eyes, resulting in poor stereopsis. To avoid this magnification, you can use contact lens as we mentioned in the aphakia lecture. If a two-year-old child writes eye refraction is +4 diopter and the left eye is only +2, so the +4 is the more ametropic. This is more ametropic. And the left eye is the less ametropic. Then the left eye is at a greater risk of developing amblyopia in the absence of in-spectacle correction. Again, this is not true because the +2 diopter is the less ametropic. So the +4 is the eye that is not seeing very well. So the brain is more likely to neglect the image that is coming from the right eye, not from the left eye. If a 4-year-old child refraction on the right eye is -2 diopters and in the left eye is ametropic or plano refraction, then the right eye is likely to develop amblyopia. Well, although the right eye is the more ametropic, but difference between both eyes in the terms of -2, it is unlikely to develop amblyopia, especially saying that it is on the myopia. If it is in the hypermetropia, if this is +2, then it could happen that the hypermetropic eye will develop amblyopia. But as we said in the lecture, the child tended to tolerate the myopia more than the hypermetropia because the whole world of the child is in them 2 or 3 meters away from him. So he doesn't need to look at the sky and he doesn't need to look to far targets. He just needs to look at the surrounding area, like his food, like his toys. So -2, if he has myopia of one eye -2 and the other eye is ametropic, it is unlikely to cause amblyopia in this condition. So again, this is wrong. So where is the right answer? In this question, there is no right answer. This question is a wrong question put by the ICO that was corrected in the next or the third year in the following year's exam, as you will see now. So here is the answer after they removed the wrong answers. Please read it and tell me what is your answer. So just to make it easier for you, C and D are the same, and A and B are changing. Exactly, Dr. Joanne, that's right. So now they figured out what is wrong with the previous question. That in the patient with high anisometropia, they will develop good stereopsis with contact lens, not with the spectacles. So this will be the right answer. As we agreed, C and D will be wrong, and the patient will not have anisoconia if one eye is pseudophakic and the other eye is phakic, as long as the refraction of both eyes will be within less than 3 diopters, then there will be no anisoconia. So having a pseudophakia is not a prerequisite for development of anisometropia. Is it clear? Please let me know if you have any concerns or if any doubts or if you have any questions. Dr. Sadia, are you raising your hand? Okay. So as we mentioned in the lecture, the etiology of anisoconia can be either anatomical or can be other optical. So optical meaning that there will be a difference. The anatomical means that there is difference in distribution of rods and cones, leading to wider distribution will lead to smaller image. Let me give you an example for this. There is a disease called the central serous retinopathy, or sometimes they call it central serous chorioretinopathy. In this disease, there will be accumulation of the fluid in the neurosensory retina or below the neurosensory retina. This will result in wider separation of rods and cones by the fluid. And so the rods and the cones will be widely separated, so they will receive the image and the patient will complain of micropsia. The patient who have a central serous retinopathy in this eye will complain that he can see smaller image with this eye. This is because not anisometropia, but due to wide separation of rods and cones. Optically, it is due to anisometropia. So this anisometropia can be due to variability in power and the position of the correcting lens, or refractive condition of the eye, or the distance of the nodal point from the retina. Okay, Dr. Sadia, you are just a little bit confusing. If a patient is a myope and he is overcorrected, this will render him hypermetrope. Again, if a patient he is myope, let's say for example he is -5, myopia. If you are putting a spectacle of -5 in front of his eye, he will be immetrope. But what happens if you put in front of his eye -7? Actually, you are changing him from immetropia to hypermetropia because the patient will need to exert his accommodation. He have or he has to stimulate his accommodation of +2 diopter in order to overcome the -2 or the added -2 that you put in front of his eye. And who is the patient who is stimulating his accommodation? He is the hypermetrope. So this patient is now a hypermetropic patient. So as we know, the hypermetropic patient will see that the green more than the red. And this is the value of this test. This test, if a myopic patient is overcorrected, he will see the green light better or the green letters better. And our aim is to adjust his myopic correction in order to make him seeing the red better, or at least the red like the green. So this is not the A. The nuclear sclerosis is increasing the myopia in the early stages. So there is what is called the senile sclerosis or senile or nuclear or the nuclear meiosis. This is caused by the increasing refractive index of the lens by the nuclear sclerosis will result in that the lens becoming more powerful or having more refractive power, resulting in more myopia. So the overall refractive power of the eye will be increasing by increasing refractive index of the lens caused by the nuclear sclerosis. So again, C is a wrong answer. Would you think of another answer? Okay, so the nucleus of the lens of the eye has a higher refractive index than the cortex. And this what will happen in the nuclear sclerosis, that the nucleus will increase in the refractive index, causing more myopia in early stages. So we have the final answer. It is that the chromatic aberrations on either sides of the point of focus of a metropic eye is 1 diopter. Actually, it is like 0.5 or 0.4 diopter, but since the question is mentioning approximately, then we have no problem with this option as long as the other options are wrong. So the duochrome test is a test depending on the principle of chromatic aberration. The patient is seeing the letters in the green light is better, or the letters in the red light is better. And this depends on the principle of the duochrome test, meaning that the yellow light or the yellow-green light is focused on the retina. On the other hand, the green light and the red light are focused in front and behind the retina respectively. So what happens if the eye is emmetrope? You will see the yellow-green light. But what happens if the eye is hypermetrope? Then the green light will be in focus. And what happens if the eye is myope? Then the red light will be in focus. So the myope will see the red light better. The hypermetrope will see the green light better. And why we are not using the blue light instead of the green light, since the blue light has a shorter wavelength and tend to deviate more and refract more, so it will be away from the retina. This is because, to make a fair comparison, the both lights should be at equal distance from the retina. And it was found that the red and the green light are straddling the retina, meaning that there are at near same distance from the retina. It's about 0.4 diopters, but in the question it is saying 1 diopter approximately. So as I mentioned, it is saying approximately, so it could be the right answer, as long as the other options are excluded as they are wrong. The refractive index of the nucleus is more than that of the cortex. So this refractive index of the nucleus is increasing by age and increasing by the nuclear sclerosis. The nuclear sclerosis or the nuclear cataract in early stages, it causes progressive hardening of the lens, this causing increase in the refractive index and causing myopic shift, or what's called lenticular myopia. So it is not uncommon when you are in the clinic and see a patient refraction who is -6 or -7 and ask him if he used to wear glasses in the past. He will say, no, I was be able to see 6 and I didn't wear any glasses, and he has emmetropic refraction. And why, you wonder, why does this happen? And why does this patient develops myopia all of a sudden? Almost always think of lenticular myopia. Check the lens. He could have a myopia, could have a nuclear cataract, and this nuclear cataract will cause a shift of the refractive index of the nucleus, causing the lenticular myopia. This is a page, by the way, from the American Academy. We didn't discuss the Worth dot test because it will be discussed in the binocular vision class in the physiology, but it was asked in the optics. You will see that there are some lessons that can be asked in the physiology or the optics. So I just brought this question because it's asked in the optics. I give you a brief about the Worth dot test. But just if you know the answer, you can tell me. Exactly, Dr. Joan. This patient who sees, and that's right, Dr. Sadia, this is correct. If a patient who is tested by Worthford dot test and see 5 dots, this means that his right eye can see 2 dots and his left eye see 3 dots, and this patient has diplopia. Not good fusion and not suppression of the left eye, as left eye suppression will result in seeing 2 dots. Right eye suppression will mean that he can see 3 dots. So a Worth dot test is a test in which it is a dissociative eye test used to test the binocular vision, in which the patient wear red-green goggles. The red will be in front of the red eye and the green will be in front of the left eye. And he is presented 4 dots. The one is red, 2 are green, and 1 is white. If the patient is normal and they can and then or if the patient is normal, he should observe 4 dots. These 4 dots are of the same of these colors. One will be red and 2 will be green, and the other one, which is the white one, will be a color in between the red and the green, like reddish green or greenish red. So he will report that there is a color in between both red and the green. This is because of the fusion of color between both eyes. If the patient has suppression of the left eye, then the patient can see only by the right eye. He will see the red dot and the white dot will be red. If he has right eye suppression, then he will be seeing only with the left eye. So he will see the 2 green with the green eye, and the white eye or the white dot will be seen green again by the left eye. So he is seeing only with the left eye and he has right eye suppression. If the patient has alternating vision or alternating squint, he will report that he can see alternating 2 red dots with 3 green dots, 2 red dots with the 3 green dots. But if the patient has a paralytic squint, meaning that the one eye is deviated, he will see diplopia, meaning that the right eye will see the red dot and the white dot with the red color, and the left eye will see the 2 green dots with the white dot seen in the green color by the left eye. So both red and both right and left eyes, everyone can see a different image from the other one. This will result in seeing of 5 dots, and this is the result of Worth dot test. So I guess that this is an easy test. Let's move to the next question. We have just mentioned that that if a patient who is hypermetrope or the patient who is wearing a plus lens like presbyope and he is undercorrected and he wants to increase the retinal image size or increase the magnification, he will push it down the positive glasses down his nose so that the refractive power will be increasing and the retinal image size will be increasing. It is better to not overpower the refractive or the reading segment of the elderly patients. So we mentioned that if we are increasing the plus lens, we will increase the magnification. So you may be tempted by an elderly patient to increase the power of the refract of the reading segment like more than +3 or +4 in order to gain more magnifying effect. But actually, this will not be correct optically because this will result in decreasing or eliminating all the accommodation that the patient has and resulting in that the patient will not stimulate his accommodation convergence reflex. So this patient will be complaining of accommodative, will be complaining of athenopia because he is not using his convergence. And as you know, for reading, we need both the plus lens or both the accommodation and also the convergence. Again, these patients will not be using their convergence because it will not be stimulated by the overpower plus lens. Myopic patient will produce a base out prism. No, it will produce a base in prism. So let's assume that this is an eye. Okay, and this is the other one. Let me change the pink color. And we are putting now a minus lens. What is the shape of the minus lens? It is a, looks like this. It is an apex to apex prism. It has a base out like this, and the apex is in. So what happens if we are shifting, if you are a patient who is myopic is looking from the near side, then he will be looking from there. Let me put you the red pen again. So his pupil will be converging. So when the pupil is converging like here, he will see through this segment. So what is the description of this segment? It has a base in. The base is toward the nose and the apex is out. So our myopic spectacles will produce a base in prism for near vision. The back vertex distance is necessary to be specified if the lens is over 5 diopters because of the changing the back vertex distance will affect the magnification as we mentioned more than once. Is it clear, Dr. Joan? Okay, let's move to the next one. This question is a little bit tricky. So pay a good attention that this patient has a corneal scar. So the question is asking specifically about the corneal scar, not an overall patient or a general patient. Exactly. I am glad that you didn't fall in the trap. So they are asking about a patient who has a corneal scar and his vision has improved by the pinhole. So for the first instance, when you see this question, you will jump to say that okay, the pinhole will work by diffraction, but actually, what happens it is that the diffraction is not the solution here. Actually, the pinhole will cause diffraction, but the pinhole will, or the diffraction will limit the visual acuity, not improving the visual acuity. This is from one side. From the other side, this diffraction can occur in all normal individuals, not specific to patients with corneal scar. The same goes with the spherical aberrations. So the pinhole will limit the spherical aberrations as well, and it can cause improvement of the visual acuity, but this is again can happen to anyone, not only patients with a corneal scar. But for this scenario, what makes the patient who has a corneal scar has poor visual acuity that improved by the pinhole, that the pinhole will overcome the effect of the corneal scar, or will overcome the irregular astigmatism caused by the corneal scar. So since the patient has a corneal scar, he will have an astigmatism. This irregular astigmatism will cause degradation of the visual acuity. But once we put the pinhole, this will result in allowing only the central light rays to reach the retina, causing improvement of the visual acuity. So yes, your answers are right. It is B. A question about transposition we mentioned about. So please let me check. Yes, I think that you are right. So it is B, sorry for that. It is 1 plus 0.75 over plus 75 axis 180. So this is not true. So Dr. Sadia is saying that hypermetropia need to be corrected if there is an ESO deviation. So let me ask you a question. If a patient is a child who is hypermetrop and is complaining of headache, so when he is sitting in his class at the school, he complains that he is complaining of headache when he is looking into his book or looking into the blackboard. So does this patient need correction or not? Yes, exactly. So astigmatism may be initially undercorrected to aid the tolerance of new glasses. It is well known that the astigmatism is not well tolerated by most of patients. So if the patient, for example, has -3 or -4, and he is wearing spectacle for the first time, it is wise to give him undercorrection in the first instance in order to make him tolerate the glasses. Otherwise, the patient can refuse the glasses and will not be able to tolerate it. So it is always advisable to undercorrect the astigmatic correction in the first instance. Cyclopegia is usually needed, especially in the children, to control accommodation. And the hypermetropia needs to be corrected if there is esodiviation. So there will be a full correction of hypermetropia. Also, if the patient is complaining, like for example, if he has headache or athenopia. The initial overcorrection of myopia may help to control the intermittent exodeviation, not the esodeviation. So if the patient has an outward deviation, this means that the patient has poor fusional control, and we can give overcorrection of minus lens in order to stimulate his medial recti to do more convergence. So this convergence will control this exodeviation. But if there is esodeviation, overcorrection of myopia will worsen the condition. Exactly. The back vertex distance is crucial for cases of aphakia in order to have an accurate measurements, because this is the plus 5 or it is more than plus 5 diopters. So adjustment of the back vertex distance will cause accurate refraction and accurate prescription of the glasses to avoid the lens magnification or to avoid improper lens magnification. It cannot be ignored for accurate spectacle correction for myopia, and it is necessary for a correction of aphakia, and it is also necessary for lens incorporating a prism. Question about Euchrome test. So, Dr. Joan, you are saying it is based on spherical aberrations. Would the duochrome test, it is called dew, meaning that it is two. Chrome, it is a color. So this is a test of the two colors. Would you still believe that it is dependent on the spherical aberration? Does the word chrome give you a clue about something else? Something. So, Dr. Sadia, what do you think? It is based on spherical aberration? Exactly. It is based on the chromatic aberration. So it depends. It doesn't depend on normal color vision, as we mentioned that the color blindness doesn't invalidate the test. As the test depends on not the ability to appreciate colors, but it depends on the ability to detect if the color is more brighter or not, and this is due to its relative position to, on the retina, or relative position to the retina. In the overcorrected myope, the letters on the green background are seen clearly. This is the true answer. It is based on the chromatic aberrations, as we mentioned, and it doesn't, or it is not tested with the red-green goggles. It is not like the Rutherford dot test. The patient is just presented a rank of red colors or letters mounted on red color and letters mounted on green color, but no need for red-green goggles. Exactly. So it is mainly compensated for by the use of aspheric surfaces in the lens design. So what is the dispersion, or what's meant by dispersion of light? Dispersion of light, or what's meant, or what's called sometimes the chromatic dispersion of light, is that the breakdown of light to different spectral constituents or different colors. This breakdown of the light occurs due to different speed of light. And why the light has different speed? This is because the light has different wavelength. So every wavelength has its own speed. Like we said in the prism lecture, the prismatic chromatic dispersion means that when the white light enters the prism causes chromatic dispersion. So it will lead to breakdown of the light into red color, like yellow color, green color, blue color. This is because of that the prism material will cause dispersion of the light, or the refraction of the light is different according to the wavelength. So the blue light will refract the most because it has the shorter wavelength, while the red color will refract the least because it has the longest wavelength. This will result in that the image will have different colors like this. The image will have a blue color, a green color, red color. This is what is meant by chromatic aberration. So how can we overcome this? This can be overcome by putting lenses with different refractive indices like the crown glass and the flint glass. This is what is called the achromatic doublet. Achromatic doublet is something that can be used for the photography lenses in order to reduce this chromatic dispersion. So for a perfect lens with no chromatic aberrations or no chromatic dispersion, the light will be focused in a single point rather than forming multiple colored images or multiple colored foci for the chromatic lenses. So let's get back to the question. The question here is mentioning it contributes significantly to image degradation. This is right. But for non-achromatic lenses, no, here is one letter make it wrong. It is A. It makes it the image degradation in non-chromatic lenses. But non-achromatic lenses, this is what we know, what we want. We want the lenses that will produce no chromatic dispersion. So it is not non-achromatic, it should be non-chromatic lenses. It's explained by the refractive index of any one of the optical medium being similar for all wavelengths. Actually, no, the refractive index is different for all wavelengths. So if it is similar for all wavelengths, this will produce no chromatic dispersion. But the fact is that the refractive index of the prism, for example, is different for the blue color and yellow color, and the green color is what's making the dispersion of light. And it is compensated by the use of aspheric surface of the lens design. So if we put a lens design that is aspheric, this will cause flattening of the lens periphery, causing more decreasing of the dispersion of light, and it has no relation to the interference phenomenon. So this is from Elkington. In the Elkington, it's talking about the dispersion of light. This sentence is present exactly as it is. The refractive index of any medium differs slightly for the lights of different wavelengths. So putting a refractive, like it will become 1.5, for example, for the red color, become 1.6 for the blue color, 1.8 for the green color. This is what's meant by the refractive index for any medium differs slightly for light of different wavelength. Okay, let me show you this from Elkington again about the reduced eye. The two focal lengths adjusted with the reference to the new principal point. This result in the reduced eye. So actually what happens in the reduced eye that it is a theoretical eye. The Goldstrand is the eye that is, or the Goldstrand schematic eye is the eye that represents the actual refractive surface of the eye. So it takes into consideration that there is one refractive medium called the cornea, and there is another refractive medium called the lens. But in the reduced eye, the two refractive media are just made into one. Has only single refracting surface. So in the reduced eye, it is a theoretical eye. So as we changed the two principal planes and the two refractive medium into one, we need to adjust the focal length accordingly. We need to adjust the focal length according to the new principal point, as the reduced eye has only single principal point, while the schematic eye has two principal points. Again, the schematic eye has two principal points. So while the reduced eye has only one principal point. So the two focal points in front and behind the principal point need to be adjusted accordingly from the schematic eye to the reduced eye. It is a more abridged form of the, or less detailed version of the schematic eye. So this is wrong. It has an ideal refracting surface because it is ideal because it is theoretical. The radius of curvature is about 5.7, and its refractive power is 58.6 diopter. This is mentioned like 58.6 in the one in some sources. Other resources it will show it is 60 diopters. There is no problem between both of them. It has a refractive index of 1.336. This is not true. This is the refractive index of the aqueous and vitreous. Yes, you are right. As we mentioned in the chromatic aberration, in the duochrome test, the undercorrected myope will see the red color more clearly than the green. So this is our aim from the duochrome test, to make the patient or the myopic patient is slightly undercorrected in order not to exhaust his accommodation. And in this case, he will see the red like the green or the red better. The chromatic aberration is reduced in keratometry by use of the green light. This is not true. We still didn't discuss the instruments, but actually this what happens in the photometer or the lensimeter, not in the keratometer. We use the green light to reduce the effect of chromatic aberration. It occurs because shorter wavelengths are deviated more in refraction, not longer wavelength, and the dispersive power of a material is not related to refractive index, as again we mentioned in the lecture, that the dispersive power of the prism is not related to the refractive index of the prism or whatsoever, or whatever the material, the dispersive power or the chromatic dispersion is not related to its refractive index. Again, as I told you, that there are some topics that can sometimes appear in the optics, sometimes they can appear in the physiology. So I preferred to those who are appeared in the optics to discuss them in the optics classes, so that for those who are not attending the basic sciences course will also know the answer of this. But don't worry, we will discuss the color vision in all details in the physiology lectures. Okay, so since that we didn't discuss this lecture in topics yet, or to discuss this question in topics yet, let me discuss it. Deuteranopia indicates the absence of red cone function. This is not true. Deuteranopia will be the green cone function, not the red, or the absence of red cone function. This is called protanopia, not deuteranopia. The T-no test is one test for stereopsis, not for color vision. So all this is wrong. TNO test employs red-green anaglyphs. Anaglyphs are just a stereoscopic photograph with two images superimposed and printed in different colors. So they will be printed in red and green to detect red and green color blindness. This is not true. They are tests. Use red-green goggles in order to detect the stereopsis. Tritanopia indicates the absence of the blue cone function. This is the true answer. And tritanopia cannot be detected by Ishihara color plates. Ishihara color plates are used for detection of the red-green blindness, which is by far more common. So this is what's meant by the T-no test. The T-no test is a test for stereopsis and use red-green goggles. If the patient has good stereopsis, he can see some images are embedded within these plates. Exactly, this is an easy question. A toric contact lens is used to correct the astigmatism, not all other options. This is true. Exactly. So as we mentioned, that the nuclear sclerosis of the lens can cause lenticular myopia. It is usually caused by relatively flat cornea will cause decreasing the refractive power of the eye, causing more to be toward hypermetropia rather than the myopia. The far point is not an infinity. The emmetropia will have a far point at the infinity. On the other hand, myopia will have far point in front of the eye, and the first principal focus will be in front of the retina, not behind the retina. Yes, exactly. So accommodation after age of 20 years old, regarding the accommodation occurs because the eye increase its dioptric power. So by increasing the eye dioptric power, this will resulting in being able to see the near targets. The amplitude of accommodation tend to decrease behind the or after age of 20 years because of decreasing the accommodation or decreasing the accommodative power. So the lens dioptric power will decrease after the age of 20. Like, let's say, for example, it is 8 diopters of accommodation in the age of 20, and become 4 diopters of accommodation at the age of 40. So what happens here is that the amplitude of convergence or amplitude of accommodation decrease, which is the difference between the dioptric power of eye at the far point and the dioptric power of the eye at the near point. Likewise, the range of accommodation will decrease. So the range of accommodation will be the distance between the eye at the far point and the eye at the near point, and this also will decrease due to recession of the near point. The far point and the near point of the eye moves further apart. Actually, no, it is that the near point will be a recession, or the recession of the near point will be more toward the far point. So this is not, they are is moving away from each other, but actually the near point become approximating to the far point. That's why the patient is not able to see the near targets as he gets older. Let me explain this in this illustration. Let's see, for example, that the patient here is looking to this book at the infinity, so he is not exerting any accommodation. This is his accommodation at rest, and this is his punctum remotum. And when this book is approximating like here, so the patient is now looking to this book and exerting and stimulating his convergence and his accommodation. So if we say that he is exerting his maximum accommodation, like if he has +4 diopters, and then his punctum proximum will be 25 centimeters. The difference between the accommodation while it's completely relaxed and the accommodation while it's completely exerted, this is called the amplitude of accommodation. And the distance between the punctum remotum and the punctum proximum, this is called the range of accommodation. So what happens with increasing the age? Actually, this number is decreasing. The amount of accommodation that the patient is exerting is decreasing. So the amplitude of accommodation is also decreasing. Also, the range of accommodation will be decreased. So let's say, for example, that this patient is now has 10 diopter, have recession of his near point after his age. So is not able to see targets at 25 centimeters, but he can see targets at like about 1 meter, because he is now having 1 diopter of accommodation. What will happen? There will be slighter difference or less difference between the punctum proximum, so punctum remotum, and the punctum proximum. The punctum proximum here now is at 1 meter, and the punctum remotum here is at infinity. So here is the range of accommodation, which is decreasing as the patient is increasing in his age. So the range of accommodation will decrease as the patient gets older. So in this question, please pay good attention that it is asking about magnification, and check whether the option are asking or mentioning myope or hypermetrope. Exactly. So it is 1.33 for 10 diopter refractive hypermetrope wearing glasses at the anterior focal point of the eye. So let's analyze this question. Why A is wrong? Actually, A is wrong because it is a minus lens, and as we mentioned, that the minus lens will decrease the size. So magnification is less in contact lens than in glasses. So here is, you can see that is minus 10 diopters, and minus 10 diopter will cause a smaller image, not a magnification, but it will be smaller image. We will agree that the smaller image will be, or the less magnification with the contact lens than those who are wearing spectacles, but this doesn't mean that the contact lens will magnify the image. It is still a minus contact lens. So minus contact lens will cause less magnification than spectacle, but it will again will cause less than the actual image size. So here one represent the normal image size. If it is more than one, then this means that there is magnification. If it is less than one, then this means that there is minification. And here the minus contact lens will cause minification. It is 1.3 for a plus 10 diopter refractive hyperope wearing glasses at the anterior focal point of the eye. This is correct. As we mentioned, in the relative spectacle magnification in case of aphakia, it will cause about 33% magnification of a plus lens placed in front of the eye in the anterior focal point. It is greater than 1 for refractive myope, more than of minus 5 diopters. Again, minus 5 diopter will cause less, will cause a lens or cause image magnification, not increase magnification, as since he is myope. And it is less than 1 for 10 diopter axial hyperope wearing spectacle at the anterior focal point of the eye. So does this mean that it will be the image will be minified if a patient is hyperope wearing a spectacle at anterior focal point? This is again is wrong. Why this is wrong? Because according to the Knapp's rule, do you remember what is Knapp's rule? If we have an axially ametropic eye, so axial myopia or axial hypermetropia, that they are wearing spectacles at the anterior focal point of the eye, then the resultant image size will be the same like the emmetropic image size. Again, What is the Knapp's rule? If there is an axially amyotropic eye is corrected by lens present at the anterior focal point of the eye, then the magnification of the retinal image size is the same like the amyotropic image size, or the relative spectacle magnification is 1. So D is wrong. But again, why B is the right one? Because we said that one of the problems appear with the spectacle correction is the magnification. So if a patient is wearing a plus 10 diopters in the anterior focal point, this will result in 25 to 30% magnification, or the magnification will be like the relative spectacle magnification will be 1.33 or 1.33. This is due to the effect of the plus lens. And this is what happens in case of aphakia. A question about the duochrome test. I think that this could be the last question. So what is the purpose of the duochrome test? Exactly, it is D, to ensure that the myopia is overcorrected, is not overcorrected. This is the main purpose of this test. Don't be deceived by the word color vision, because this test doesn't examine the color vision, but it is examining it is a test based on the chromatic aberration to check for overcorrection of myopia. So I guess that this is the end of our lecture today. I hope that you enjoyed it, and the question of the optics become more clear. I know that they are difficult, but don't expect that these questions can be answered from the first reading. As I mentioned in the last lecture, you need to read the optics in more details, more than once, in order to grasp all ideas. Because as you can see, that a single question can be asking many topics or different topics in the optics. So you have that the optics should be clear in your mind by reading and connecting the different topics together, so you have the full idea about the topic. Also, I wanted to remind you of our test tomorrow. It will be the anatomy test. It will be 60 questions in 1 hour. So I hope that you had enough time to prepare yourself and to read the anatomy in more details and to revise the MCQs. Do you have any questions? What is the marks distribution optics chapter wise, as you mentioned in the anatomy? Do you mean in the exam or in the quiz that we will take after the optics? In the exam, they don't have a specific marks distribution. So the exam usually starts by the physical optics and the geometrical optics. It will be like 10 to 15 questions. Then they will go through the some of the human optics and the miscellaneous topics, like for another 10 to 15 questions. And then the last section will be about 10 questions for the instruments. So the arrangement of the topics is that the same like the arrangement of lectures, but actually they don't have a specific number of questions for each topic. Thank you very much for your attention and for your participation. I appreciate that you appeared for the live class today. I don't know why other members didn't join us, but I appreciate that if you try to join the live class as much as possible. This will give you a more interactive experience and will make you remember the questions and explanations better than just listening to them by your own. Okay, thank you, and see you tomorrow with the exam of the anatomy. And good night.